Hello friends, welcome to Shiksharthi. In this session, we shall be talking about conceptions and misconceptions, and while doing so, we'll be using the topic domain, range and graphs. So let's start. Now, when we talk about conceptions and misconceptions, the basic agenda is to remove uh, the misconceptions or most of the times the errors that we do knowingly or unknowingly with the help of conceptions, with the help of concepts. And for this, I am taking two different functions here. One function is fx is equal to x divided by x, and the other function that I am taking here is gx is equal to 1. Why do I call it as two different functions? Because one of them is a linear function. I mean, should I say that one of them is a linear function? No, none of them is a linear function. One of them, which is gx, is a constant function, and the other function is a combination of two different functions. So let's first try and understand how is a combination of two or more functions given rise to. Let us first try and understand that. So can I write x divided by x as x into 1 by x? This is one of the ways of writing it. Now, even before I do this, let me talk about, if I say that fx is a combination of two functions, let us try and understand that how is a combination of two functions worked out. So for example, if I take the basic function as fx, and let me take one of the function as f1x and the other function as f2x. So using different mathematical operators in between, and here I am basically referring to the basic mathematical operators of addition, subtraction, multiplication and division, to form a composite function. So what is a composite function? A composite function is formed because of two or more functions facilitated by mathematical operators. Okay, now in this case means when I'm talking about the function fx here, can I say f1x I have assumed as x, and f2x I have taken it as a different function which is 1 by x, and what is the mathematical operator that I'm using in between is multiplication, and eventually the function that I'm getting, which is fx, is x into 1 by x. What is the common error that we do here, which falls under the head of misconceptions? The common error is we are in a habit of doing inertial mistakes, and the mistakes are x and x, they have a common factor as x, so cut the numerator by x, cut the denominator by x, and eventually you write it as x divided by x is equal to 1. Eventually when you write this, that means you are talking about the range of the function. But even before you come down to the range, we know that the domain is the launch pad to the question, which is why when we are saying that this topic, when we are discussing this series of conceptions and misconceptions using the topic of domain, range and graphs, it is all the more necessary for you to go through all the sessions that we would have done on these topics, so that you can understand this in a better manner. Okay, now once you have understood this, it's not only that I could have used a multiplication sign. I could have said that f1x also I am taking it as x, f2x also I could have taken it as an x only, and then I could have said what? The mathematical operator that I am using between and x and another x is division. But anyway, so now when I am finding out the domain of fx, so the domain of fx will be nothing but domain of f1x intersection with or intersected with the domain of f2x. If we had a combination of 3 or more, in that case we will take the intersection of all the domains of f1, f2, f3, all those functions which are responsible in forming the ultimate function, which is fx. So in this case, when I'm trying to figure out the domain of fx, so the domain of fx will be what? Let's try and figure it out. So what is the domain of f1x? We know that the domain of x is real numbers, and we can find it out also. What is the domain of 1 by x? We know by now that the domain of 1 by x is x less than 0 union with x greater than 0. Now when I take the intersection of both of these, so one is you take this domain and you take this domain, and then you take the intersection of this, eventually you get the domain as x is greater than 0 union with x is less than 0 along with x is greater than 0. This is the domain of the function fx. Now it is when you have specified the domain of the function, then only you are eligible to perform any mathematical operation on a function. So once you have specified this, then you will say fx is equal to x divided by x, and you cut it with the help of a common factor, and eventually you write it as fx is equal to 1. So I hope you would have understood what is the mistake that we do, which falls under the category of misconceptions. Either you did not have any concepts at all, or you were using your concepts wrongly. So please remember, henceforth, whenever you are performing any mathematical operation on a function, the answer that you are getting is the range or the solution. The range, even before the range, you know that the function, the domain of the function is the launch pad to the function, which needs to be specified even before you target its destination, and the destination is the range of the function. Now, if I were to draw the graph of this function, so the graph that I'm going to draw here is, so let us say this is the positive hand of x-axis, this is the negative hand of x-axis, positive hand and the negative hand of y-axis. Okay, so now let me make the graph fx is equal to 1, but we know that x is less than 0 and x is greater than 0. So the graph that I have drawn with the green color is the graph of the function fx is equal to x by x, which also can be written as 1 under the domain constraints. And we know that this point is nothing but the neutral point. And I hope by now you know that when we are putting an arrow means that the point next to it is excluded. Okay, let's see the constant function gx is equal to 1. Why do we call it as a constant function? Because it doesn't have any power of x. Or another way to understand the same is, this could have also been written as x to the power 0, where x is my independent variable. But the moment you write it as x to the power 0, in that case you would say that x should not be equal to a 0. So this kind of a presentation should be avoided, and this is how you call this as a constant function. A constant function is nothing but a number, either it could be a fraction, a negative fraction, positive fraction, unity fraction, integer, negative integer, positive integer, neutral integer. These all, they fall under the category of constant numbers or constant functions. Okay, now if I have to specify the domain of this function, I know that the domain here is, either I say real numbers or I say x extends from minus infinity to plus infinity. This is what I can say. If I had to draw the graph, I can draw the graph also as I had drawn in the earlier case. The only difference being here I'm going to draw the graph of gx. So negative hand of y, positive hand of y, positive hand of x, negative hand of x, the point of intersection of both the axes, which is the neutral point, and then we make the graph after this. So this is the graph of gx is equal to 1, which is defined for all values of x. So what is the final learning from here? Can I say fx is equal to gx? I can say this with some domain riders. What are the domain riders? Yes, fx is equal to gx given x is less than 0, union x is greater than b. For these conditions only both the functions are equal. Can I say fx not being equal to x? Yes. And from where does it come? It comes from fx is equal to gx only. Fx is not equal to gx when x is equal to 0, because they cannot be equal, because one of the function is not defined for x is equal to 0. I hope this session on conceptions and misconceptions helps you to improvise upon your earlier learnings and take your new learnings even to the next level.